Learning new things can be tough. It's something we all experience, no matter our age or background. Whether you're trying to master a new language, pick up a musical instrument, or just get through a challenging math assignment, the struggle is real. Sometimes it feels like your brain is working against you, putting up invisible walls that make progress slow and frustrating. We've all been there, right? That moment when you look around and realize everyone else seems to be getting it, while you're stuck on the same problem. It can feel isolating, but the truth is, everyone faces these hurdles at some point. Even the most successful learners have moments of doubt and confusion. You start with excitement, full of motivation and hope. Maybe you've set up your study space, gathered your materials, and told yourself, this time, I'm going to nail it. But as you dive in, the material gets harder. Concepts that seemed simple at first suddenly become complicated. Frustration sets in, and you might even start to question your abilities. Why is the human brain wired this way? Why does it sometimes feel like our minds resist learning, even when we want to improve? The answer lies deep in our evolutionary history, in the way our brains have developed over thousands of years. Our brains are incredible organs, but they weren't designed for the modern classroom or the digital age. Instead, they evolved to help us survive in a world full of immediate dangers and challenges. Quick thinking and fast reactions were far more important than sitting still and absorbing complex information. Imagine our ancestors on the savannah, thousands of years ago. Their daily lives were filled with uncertainty and risk. Every day was a test of survival, not just intelligence. Their brains needed to react fast to danger, like spotting a predator in the grass or hearing a sudden noise in the dark. In those moments, there was no time to analyze or overthink. Instinct and quick decision-making were the keys to staying alive. Learning new hunting techniques or how to find edible plants was important, but not dying was more important. The brain prioritized immediate survival over slow, deliberate learning. That's why, even today, we sometimes find it easier to react quickly than to sit down and focus on something new and complex. So, our brains are naturally good at recognizing patterns and making quick decisions. We're wired to notice when something changes in our environment, or when a familiar pattern is broken. This skill helped our ancestors avoid danger and seize opportunities. But learning something completely new, that takes effort. It takes focus, patience, and a willingness to push through discomfort. Our brains have to build new connections, strengthen unfamiliar pathways, and sometimes even unlearn old habits. That's why it can feel so exhausting. And honestly, our brains aren't always eager to do the work. They'd rather stick to what's familiar and easy. But don't despair. This resistance isn't a sign that you're not smart or capable. It's just your brain's way of conserving energy and avoiding unnecessary risk. Understanding how our brains learn is the first step. When you know why learning feels hard, you can start to work with your brain instead of against it. You can develop strategies to make learning more effective and less stressful. We can train our brains to learn faster and more efficiently. With practice, repetition, and the right techniques, you can actually rewire your brain to handle new information better. Memory exercises, active recall, and spaced repetition are just a few tools that can help. Collaboration and creativity also play a huge role. When you work with others, share ideas, and approach problems from different angles, your brain forms stronger connections. Learning becomes a social and dynamic process, not just a solitary struggle. Taking breaks and practicing mindfulness can also help. When you give your brain time to rest and recharge, you come back to your studies with renewed energy and focus. Sometimes, stepping away for a moment is the best way to move forward. We can even make it fun. Turning learning into a game, celebrating small victories, and finding joy in the process can transform the way you approach challenges. Remember, every step forward, no matter how small, is progress. So the next time learning feels like an uphill battle, know that you're not alone, and that your brain is capable of amazing things. The science of learning is revealing incredible secrets about our brains. One scientist, Anders Ericsson, spent decades studying experts. He wanted to know what made them so good. His research led to the idea of deliberate practice. Deliberate practice isn't just mindless repetition, it's about pushing yourself beyond your comfort zone. Identify your weaknesses and focus on improving them. Get feedback from experts and track your progress. Think of a professional athlete. They don't just show up and play, they train intensely, focusing on specific skills. They review their performance and strive for constant improvement. That's deliberate practice. Deep inside your brain, there's something truly remarkable at work, a substance called myelin. You might not have heard of it before, but myelin is one of the unsung heroes of your nervous system. It's a fatty layer that wraps around the long, thread-like parts of your nerve cells, called axons. This wrapping is absolutely essential for your brain to function at its best, and it plays a huge role in how quickly and accurately you can learn new things or master complex skills. Think of myelin like the insulation you see on electrical wires. Just as that plastic coating keeps electricity flowing smoothly and prevents short circuits, myelin insulates your brain's wiring, making sure signals travel where they're supposed to go, fast and without interference. Without this insulation, your brain's messages would get lost or slow down, making it much harder to do even simple tasks. This insulation is what allows signals to zip along your nerves at lightning speed. It's the reason you can react quickly in sports, solve problems efficiently, or type rapidly on a keyboard. The more myelin you have around a neural pathway, the faster and more reliably those signals travel, making your actions smoother and more precise. Here's the really fascinating part. The more you practice a skill, whether it's playing an instrument, shooting hoops, or writing neatly, the thicker and stronger this myelin sheath becomes around the pathways you're using. It's like your brain is reinforcing the roads you travel most often, making them wider and easier to drive on. Daniel Coyle, author of The Talent Code, explains that myelin is the secret ingredient behind skill development. According to his research, every time you practice deliberately, meaning you're focused, pushing your limits and correcting mistakes, your brain responds by building more myelin. This process is what separates average performers from true masters in any field. When we engage in deep, focused practice, we're not just repeating motions, we're actually triggering the growth of myelin. Each repetition sends electrical impulses down specific neural circuits, signaling the body to lay down more myelin and make those circuits even more efficient. Over time, this is what transforms awkward, effortful movements into smooth, automatic skills. More myelin means your brain can send signals faster and with less effort. That's why, after enough practice, you can perform complex actions, like playing a fast piano piece, or making a split-second decision in a game, almost without thinking. Your performance becomes faster, smoother, and more automatic, as if your brain is running on a supercharged network. To really understand how this works, imagine learning to ride a bike for the first time. At the beginning, everything feels strange and difficult. You're trying to balance, steer, and pedal all at once, and your brain is scrambling to coordinate all these new movements. At first, it's awkward and wobbly. You might tip over, lose your balance, or forget to brake in time. That's because your brain hasn't yet built up enough myelin around the neural pathways needed for biking. The signals are slow and sometimes get mixed up, making the whole process feel clumsy. But with every practice session, your brain is hard at work. Each attempt, even the failed ones, helps your brain identify which pathways are important. As you keep practicing, myelin starts to wrap more tightly around those circuits, making the signals faster and more reliable. Gradually, you notice you're balancing better, steering more smoothly, and pedaling without thinking so hard. Eventually, riding a bike becomes second nature. You can hop on and go without even thinking about it. That's the magic of myelin at work, transforming your brain's wiring so that what was once difficult now feels effortless and automatic. The more you practice, the more myelin you build and the more skilled you become. Our brains love patterns. From the moment we're born, our minds are constantly searching for order in the chaos around us. Whether it's recognizing faces, learning a new language, or figuring out how to solve a puzzle, we're wired to look for connections and similarities. This natural tendency helps us make sense of the world, and it's a powerful tool when it comes to learning new things. But here's the thing, we're great at remembering stories, but not so great at remembering random lists. If you've ever tried to memorize a long list of unrelated items, you know how quickly your mind starts to wander. It's like trying to hold water in your hands. Most of it just slips away. Our brains crave meaning and structure, and when information is presented without any context or connection, it becomes much harder to retain. That's where chunking comes in. Chunking is a strategy that takes advantage of our brain's love for patterns and organization. Instead of trying to remember a long string of separate facts, we break them down into smaller, more meaningful groups. This makes the information easier to process, store, and recall later. Chunking is the process of grouping information into smaller, more manageable pieces, It's like turning a mountain of information into a series of small hills. By organizing data into categories or themes, you give your brain a framework to hang on to, making it much less overwhelming. Think about phone numbers for a second. Most phone numbers are 10 digits long, and if you tried to memorize all 10 digits as a single string, it would be pretty tough. But when you break them into groups, like 3 digits, then 3, then 4, it suddenly becomes much easier to remember. We don't memorize them as 10 random digits. Our brains naturally look for ways to simplify and organize information, and chunking is one of the most effective ways to do that. We chunk them into groups of 3 or 4. This simple trick transforms a confusing jumble of numbers into something familiar and easy to recall. It's the same reason we break up long words into syllables or divide a big project into smaller tasks. This just makes them so much easier to remember. When you use chunking, you're giving your brain a shortcut, a way to bypass the overwhelm and focus on what matters most. Suddenly, what seemed impossible to remember becomes totally doable. When you're learning something new, look for ways to chunk the information, create categories, find relationships, and connect new ideas to things you already know. The more connections you make, the stronger your memory becomes. And use visual aids. Diagrams, mind maps, and color-coded notes can all help you see the bigger picture and spot patterns you might have missed. Visual tools make abstract ideas concrete, and they're especially helpful for visual learners. Chunking turns overwhelming information into bite-sized pieces that your brain can easily digest. By breaking down complexity, you make learning not just easier, but also more enjoyable and effective. So next time you're faced with a mountain of information, remember, chunk it, organize it, and watch your understanding grow. Our brains are like sieves. New information tends to slip away quickly. But there's a powerful technique to combat this spaced repetition. It's all about reviewing information at increasing intervals. Here's how it works. Review material shortly after learning it, then again a day later, then a week later, and so on. Each time you revisit the information, the memory becomes stronger and longer lasting. Think of it like building a muscle. You don't get stronger by lifting weights once. You need consistent workouts spaced out over time. Spaced repetition is like a workout for your brain. One of the most effective ways to learn is to teach someone else. This is the essence of the Feynman Technique, named after the famous physicist Richard Feynman. Here's how it works. First, choose a concept. Next, explain it simply, as if you were teaching a child. Then, identify your gaps in understanding. Finally, go back and learn the parts you struggled to explain. Teaching forces you to organize information in a clear and concise way. It exposes your weaknesses and honestly forces you to actively engage with the material. It's like having a built-in study buddy. Learning is a fundamental human capability. It's how we've evolved and thrived as a species. Don't let the initial struggle discourage you. Your brain is capable of incredible things. Embrace the process of learning. Be patient with yourself. Celebrate small victories. And remember, the more you learn, the easier it becomes to learn even more. The tools and techniques we've discussed are like superpowers for your brain. Use them wisely, and you'll unlock your potential to learn faster and master any skill you set your mind to.